So just to introduce the whole idea of method development, we understand that there quite often are many pains that are associated with working in the laboratory, and this is how people that are working on the day-to-day grind often feel is like, how can I go about solving my problems in as pain-free method as possible? So our goal for this webinar is to show some of the tools that are available out there, both on the web as well as paid software. And so we want to draw your attention to all of these different ideas that could help you with your pain relief. Now, obviously, we're going to focus on and present some of the tools that we have available, both for free as well as in a paid version of our software. But oftentimes there are many resources out there that you can go and Google to look at all of the different options you have. So typically, if you're an analyst within a laboratory, you're given a sample and you're told, I need this separated and this is my compound of interest. So your end goal is you want to put this on your HPLC and you want to have a fully resolved chromatogram within a decent runtime. And ideally, if this is routine analysis, all that's required is you to put it on the GC. This is the result you get, and you're happy to send your report on to whoever requested it. Now, with samples, there can be potential limitations. Say for the vial with the red dye that I'm showing here, you may have sample restrictions. So this will limit you in your ability to, say, do some trial and error screening runs if the sample is very precious and you don't have as much as you do in, say, the yellow vial. So that can be an obstacle that's thrown your way. Oftentimes, as a chromatographer or an analyst, you're expected to know which columns will help for particular separations of interest. So if you're lucky enough, there may be a few variety of columns that are present, and so this is something that you can either archive yourself or you have a bit of a knowledge on previously. Now the hope is that this column is readily available for you to use for the separation. Now, as everybody's usually well aware, you're often under time constraints to perform such analyses, and there could also be budgetary or resource constraints as well, such as, say, if the price of acetonitrile skyrockets and you then have to limit the amount of trial runs that you're doing to do your method development because the solvent is so precious. So scenario one, which would be the best case scenario, is you are given a molecule and you're told that you need to separate it. So you go over to HPLC, you look at your standard methods, whether it's in a binder or stored on an archive somewhere on a computer, and you say, hey, I've actually got a standard method already for this class of compounds, or maybe this compound directly. So I put it on my HPLC, I do the run, and I'm happy and I get the results. Now we know we don't always live in an ideal world, and oftentimes there can be some optimization required to a standard method, for example. So say you've got a standard method, or maybe the method is for a previous HPLC, or it's not quite pertinent to the compound of interest. So this would require some optimization. How do you go about doing that? Again, are you doing trial and error, or are you using some in-house knowledge for this? Perhaps the column that is associated with a standard method is not available. Perhaps it was discontinued, or it's on back order and you're not going to get it for 6 weeks. However, this project is at a stalemate until you're able to do the separation. So again, this is how are you going to go about trying to solve this problem. Ideally, your favorite HPLC is available and the one you've got everything optimized for, but that's not always the case, and you may have to transfer to an older instrument that's there in backup, and a lot of the parameters may not be valid from your standard method. So then again, are you going to do a lot of trial and error to figure out how to best translate the method here? Or you may be trying to go from an HPLC to a UHPLC. And again, how are you going to go about trying to start this? And even if you run a standard method and you think everything is good, but your compound of interest is in fact not fully resolved based on this sample. So again, this will require you changing particular conditions such as temperature or gradient to try to better resolve this peak. And also, perhaps if this compound is going to be part of a larger screening run, ideally you would like to have the runtime as short as possible without losing any sort of resolution capabilities. So with just these few examples that I've talked about within this scenario, you can see that this in fact may be a daunting task, and it may be hard to figure out where exactly do I begin as an analyst here. Now, with scenario 2, you at least had somewhere to start, and you had, say, a method that you could try to optimize. Now, scenario 3 is, say, you are new to the laboratory, you're in a new startup, and your boss tells you you just need to separate this column, go, which can happen to people. So you can essentially start from scratch. So if you're lucky, perhaps there's a couple of experts available to you either in your lab or in a department that you can bounce ideas off of. And as long as they're continuing to work for you, that knowledge will be there. However, if they retire, move on to new positions, you may end up losing that knowledge because it will go out the door with them. Another option, which is not uncommon, is to just start flipping through a vendor catalog and you say, you know what, this column has been discontinued, what's this vendor make that's the closest thing? And this can be completely hit or miss. You can scour the literature if you're lucky enough to have a few subscriptions to see if there is a method that has been published that's out there, but this can be quite daunting as well as time consuming. So again, it's a cost-benefit analysis, so the amount of time you're going to spend doing that. And although we don't necessarily condone this, what can potentially happen is you may just decide to take the sample and put it on the column that's already installed using the method that was last run and just cross your fingers and hope you get lucky. And although this may work 1 out of 100 times, what are you going to do those 99 other times? So I've presented and introduced to you here several examples or scenarios on some of the pains that can be associated with different levels of method development. And we've identified 3 main ways that we believe software can really help get you started with your method development. The first being databasing. So if you're able to capture all the work that's being done within your laboratory and archive it in a structured environment, this could save you time later, say 3 years down the road, a compound comes for separating, you can quickly query and look it up. The second would be phys chem predictions. So there are physical chemistry properties for particular compounds that can be quickly calculated within software, and that will allow you and assist you with your separation, as well as there are a few software chromatography specific tools, both in the form of freeware as well as paid software, that can help you assist with your method development to help you achieve what you need to achieve in a timely and efficient manner. So I would like to hand things over now to my colleague Anne-Marie, who's going to talk to you about some of the specific solutions that are offered within the ACD Spectris platform.
Thanks, Brent. So one thing that I'd just like to mention is that we're aware that in a laboratory you have many different instruments, oftentimes from different vendors. So maybe you have an MS from one vendor and an NMR from someone else. One benefit of the Spectris platform is that it is vendor neutral. So you can import data files from any of the major instrument vendors and process all in one platform. So this makes it so that your your chemists only need to use or only need to learn one type of software, which can be quite beneficial and reduce some time in that sense. Now, one way that software can help is through databasing. So maybe a compound was previously separated, and so if you've created a database, you can choose to search by exact or similar structures. Now, if you're searching by exact structures, you will maybe get your actual method, which is ideal, and not have to go any further. It works, that's great. Alternatively, you could search by similar structures and get yourself a starting point. So this all will help speed the method development process because you actually have something to start from. Now, if you do a search and you find out that you have a query, you now go into your database. Now, from the database, there's a lot of different information that's been stored. For instance, you have your molecule, your analyte of interest. You have your chromatogram, all of your chromatographic results, so in your table of peaks, your retention times, peak widths, and one of the most important things that I find is that you have all of your chromatogram parameters. So your mobile phase, what solvents did you use? You've got the flow rate that was used, the gradient. So any information that the user put in when creating that database is stored here, and you can easily access this information and get a starting point of where to go. Now, you can also store your project name, the user that input the data. You could have your lab book information so that if you wanted to refer back to the lab book, you could actually do that. So this is all ways that databasing can actually help you. Now, the other benefit here is that if you double-click on the chromatogram, you actually open up the data into our Spectris environment. So you can see here on the screen it says live data. Now, what does this mean? Well, say the first person that went and stored this information in your database was only interested in that first peak, the one that says 14.14. Now, if that's all they were interested in, they might not have peak picked everything else. They may not have gone into the baseline. So with this live data environment, you can go into the data and reintegrate and get the information that you actually need. So you have full processing capabilities years later. You don't need to go and search through lab notebooks. You don't need to try and find data on some chemist's hard drive who is no longer with the company. It's all stored in one place. Now, another way that software can help is through phys-chem prediction. Now, oftentimes, one of the things you need to decide is what pH of mobile phase you need to use. And typically, you want to be maybe 2 units away from the pKa of your analyte to make sure that your analyte's not rapidly converting between different ionized forms. Now, using phys-chem prediction tools, all you have to do in this case is input your molecule and click a button and your pKa will come up. So this gives you your starting point of where to figure out your pH of your mobile phase. From here, it's up to you what you decide to do with the information. You could save the information in a database, use it in a report, or in an SOP. That's completely up to you. Now, another way that you can speed your method development is through the use of different tools that are available. Now, in this case, we're talking about a column comparison tool. So you might need to find a new column to use. Maybe you need to translate a method, or the column that you were using is discontinued, or you don't have it available anymore. Someone else in the company is using it, and you need something else right now. And your SOP states that you can use a similar column. So in this case, you can select the column that you're actually interested in, select the second column that you want to compare to. Now, the program automatically calculates a column distance factor, or a CDF value. A CDF value being low means the columns are very similar, and a value that is high is quite different. So it's up to you. Maybe you want to find a column that's significantly different because you weren't able to achieve separation. It's another way that this tool could be used. Now the CDF value is calculated based off of the 6 Tanaka parameters. So these parameters are automatically set to be equal weighting. If one of these was more important to you or not important at all, you can simply edit these parameters and the CDF value will adjust. Now, another nice feature here in the full version is that you get these radar plots. And with the radar plots, you can visually represent the space that that column occupies within the 6 Tanaka parameters. And this is shown for both column 1 and 2. And in the background of column 2, you can see a slight gray background in certain areas, and that's referring to all the other columns that are in the database, and you can now see what space they occupy. Maybe you can select a different one from there that will help you better if you're more of a visual person rather than numerical. Now the other nice feature here is that if you know your 6 Tanaka parameters for a column that's not listed in our database, you can add a new column. So you're not limited by what's listed here. Now another tool that we have available is our LC Method Transfer Assistant. So this is meant to assist chromatographers in translating between different LC formats. So maybe you need to translate between HPLC and UHPLC, or maybe you're simply moving from a newer to an older instrument, as Brent had mentioned earlier. Now with this, all you need to do is, if you've already run your method, you can import that data, and from the metadata, your original section will be filled out. If you don't have something that you've already run, you can simply enter this. Any of those boxes that have that paper and pencil are the boxes that you can actually edit yourself. Now you select the parameters that you want to translate the method to, and then the software will suggest the new parameters. Now, depending on availability, you might need to tweak a few of these parameters, and that's again why some of these boxes have the edit option. Now, a nice feature here is that if you're not sure what one of these parameters really does, what the background is behind it, we have additional information from experts in the field that is listed here. So as you click through different cells, the information on the side panel will change, and this will help guide you through translation. Now, once all your adjustments are done, the new gradient will be shown. And so in this case, we took a 30-minute method and reduced it down to a method that's less than 4 minutes. So a lot quicker than the trial and error of going through translation yourself. Now, these tools are available online. So what was shown here today were the full versions, but we do have free versions available in the resources section on our website, and the links are provided below. Now, today we've shown you how to save time, energy, and resources, and so we've done this through databasing. So showing you that you can store data in a database, you can search this later on. You're not restricted to loss of data there. Another way that we've done this is through PhysChem prediction. So the use of pKa predictors to help pick your pH of your mobile phase. And finally, we showed you some chromatography tools that will help you find new columns for method development and maybe speed method translation.